All right, so welcome back. Today in this video, we're going to be wrapping up statics, a civil FE exam review, and we're going to be going through static friction. So if you haven't went through the other videos that include resultant forces of systems, equivalent force systems, all the way down through area moment of inertia down here, then you're going to want to make sure you have watched those videos so that you have mastered all of the static section. But last section, static friction. So let's go ahead and jump into the practice problem. So this one says a 200 Newton box is placed on a 30-degree inclined plane with the coefficient of friction equal to 0.3. Determine the normal force and frictional force acting on the box. All right. So given we got a box, and they give the box weight, all right, and they say it's on a incline, and they also give the efficient of friction. All right. Okay. What are we trying to find? The normal force and the frictional force. Cool. What formulas do we need? So normal force, frictional force. Look up friction. Okay. When I look in statics and go to friction, I find something that helps me. Says the largest frictional force, friction, any other increased forces will cause motion. Okay, so F is frictional force. Are we given the coefficient of static friction? Yes, 0.3. So we have that. We're trying to find normal force and the frictional force. Okay. So maybe drawing will help us in this situation. Drawing this out. All right, so we have this incline, all right, with our little box. Okay. And I know that this is gonna be 30 degrees. And we have a force acting downward on it. That is 200 newtons. Okay. That's the weight. It's acting straight down, right? All right. So how do we get what is the normal force? All right. So what is normal force? Well, normal force always acts perpendicular to the plane. So I know that this is my normal force. Because it's acting perpendicular to that plane, right? So you could say this is force normal, Fn. All right, are there any other forces that are acting? All right, well, we got if this is coming straight down, these have to connect, right? So if we got this going all the way, let's just say that forces continues to be perpendicular. This one, they have to connect, right? The vectors have to connect. So that's the force that could be causing it to try to slide. Right. So all in all, you have something perpendicular and parallel, you know, causing this weight is causing it to do something, right? And there's a level of friction that's trying to act equal and opposite to keep this thing from slipping. Well, I don't know if it's trying to keep it from slipping, but naturally there's going to be some friction there. But right now what we need to find is the normal force. So I'm going to do the sum of the forces. Right. Okay. And if I know that we have we got this coming down, but ultimately equal and opposite force should be holding it up. All right. So that's what that normal force is going to be doing. So I know that forces in the the normal force is going to equal 200, right? And you're going to look at the angle here. What's this angle? Right, because this is kind of acting as the hypotenuse of this triangle, right? So that this angle here and this angle here are going to be equal, right? Based off, parallel axes, right? So I know that it's going to be 200 cosine of 30 to be my force normal. What about my sliding force? Well, get rid of that. So my force sliding would be the same thing, but it'd be 200 sine of 30, right? All right, we don't need the force of the sliding. We just need the force of the normal force. Right. So for my normal force, get that to equal 173.21 newtons. All right. And once you have your normal force, now we can go in here and calculate trying to highlight just one piece of this, but basically now we can go in and calculate our force of friction, or F. So F is equal to mu sub S times our normal force. Well, we have our normal force, which is 173.21, and we have our static friction, our coefficient of static friction, which is 0.3. So if we plug those in, let's say is equal to 0.3 times 173.21, and that gives us our force of friction to be 51.96. All right, so I get A for this. So main thing is knowing how to draw your forces, how to knowing what normal force actually is, and knowing that normal force is always going to be perpendicular to your surface. So in the event where there was no sliding, okay, we would have the weight of the object, and the normal force, this would be force normal. It's always perpendicular. This is the weight. So if we would have done the sum of the forces of this one, right, is equal to your force normal minus your weight, or weight is equal to force normal. Right, and so in this same case, we just added an angle to this. So instead of this surface being what it is, we just tilted that surface, and so our force normal was still equal to the weight, but we had to make sure that we accounted for the adjustment with the angle. So something to keep in mind. All right, number 2. So it says, what factors determine the maximum static frictional force between two surfaces? Okay, we're given, we want this to be the max static friction force. Okay. And we also are trying to find the factor that determines this. So, or factor or factors. Okay, so the coefficient of dynamic friction and weight of object. So I'm still in the friction section, and I know that a friction force is determined by the coefficient of static friction and normal force. So I know that to get the biggest static friction force, I'm going to need the biggest amount of coefficient of static friction and the biggest normal force. So dynamic friction isn't dynamic friction isn't dealing with static friction. Okay, coefficient of friction and surface roughness. Surface roughness doesn't affect that. Nope. Coefficient of kinetic friction, acceleration due to gravity. No, has nothing to do with that. And then coefficient of static friction at normal force. So in this case, D. Now, the normal force, sometimes it will be affected by gravity, but you're looking at normal force normally for friction, especially static friction. Normal force and those coefficients of static friction is going to give you the largest frictional force, which is called limiting friction, which it says here. Alrighty, let's look at number 3. All right, it says a box with a weight of 50 newtons rests on a horizontal surface with a coefficient of static friction of 0.5. Determine the maximum horizontal force that can act on the box just before it moves, right? Okay. So let's look at this. What information are we given? We're given the weight, also given static friction coefficient, and we want to determine the max force. So if we just draw this out, right? We have this here. We got this red box. It's very dangerous that you should not touch. And it's coming down at 50 newtons. Right? Now, you got static. We got this max horizontal force where we got this person, he's going to be pushing this box. And then you got this, the ground that has this frictional force, right? Static friction force. And they pretty much want to know what's the maximum amount that he can push without this thing moving, right? All right. So just want to search something real quick. There is a section in the handbook where it talks about slipping. Okay. And this is also in another portion of the handbook, but talks about slipping and what you need to know. So in general, the frictional force is less if the frictional force is less than the coefficient of static friction times the normal force, then no slipping occurs, right? If the force, or sorry, if the force is less than the coefficient of static friction times the normal force, then no slipping occurs. So if the frictional force is equal to the static friction times the normal force, this is at the point that it could begin slipping. So that's what we want to find, literally the max. This is right at the point before it can begin to slip. And so Really, if I know that sum of the forces in the y is equal to is always equal opposite force normal. So I got negative 50 newtons plus force normal. 50 newtons equals the normal force. All right. So now let's get the force of friction. All right. Because now I have the normal force. So anytime you're dealing with friction, you need the normal force. So force of friction right at the point at which it could, the point of impending slip, or right before it moves, just before it moves, is going to be this. So force of friction is equal to, well, static friction is 0.5. Normal force is 50 newtons. And so the force of friction, the max horizontal force that can take place, is going to be equal to 25 newtons. So if he pushes any more than 25 newtons, then it's going to move. If he pushes less than 25 newtons, it's not even going to think about moving. But at the point of 25 newtons, it's the point just before the box moves. So hopefully that makes sense. So this concludes the statics section of the Civil FE exam review. Quite a lot that we have went through. So run through the practice problems. Also check out more review in the guide. There's more practice problems in the guide. So if you felt like any of this stuff was unclear, go to the guide, do more practice, check your solutions, and then you hopefully will have mastered this section. So thanks for watching. See you all in the next section.